So we're looking at hypotenuse, leg, triangle congruence in this podcast. So looking here, are the two triangles congruent? We look and we see that they're right triangles. So if they're right triangles, say if hypotenuse leg works. It's not going to work all the time. Sometimes we have other triangle congruences that would work. Sometimes the triangles aren't congruent. But be thinking hypotenuse leg if your triangles are right. So recalling that the side opposite the right angle is the hypotenuse. And the sides in a right triangle are called legs. We have AC congruent to RT. That's our hypotenuse. It's opposite the right angle. And we have CB congruent to TS. That's the leg of the triangle. So by hypotenuse leg congruence, triangle ABC is congruent to RST. All right, let's look at another problem. There we go. All right, so is it possible to show that triangle JGH is congruent to triangle HKJ using hypotenuse leg congruence theorem? Explain your reasoning. All right, so we're going to do this one as a two-column proof. So I'd like you to take notes, and you'll turn those notes in tomorrow. So let's take a look at this one. So always start with the information that you're given. All right, so the first thing I can say is that JG is congruent to, I want to make sure I match up the corresponding parts. So J goes with H because G and K go together, right? So it's congruent to HK. And the reason, let me just put statement and reason. All right, statement. So on your paper, you'll write statement, and then we'll put reason. All right, and our statement is that GJ is congruent to HK. The reason is that's given. All right, we see there's a congruence marking on the figure, on that segment there, so that's given information. We can also say that angle G and angle K are right angles. Okay. And again, that's given. Right, so that's all of our given information. But there are some other congruences we can say. We can also say that JH is congruent to HJ. Okay, those are opposite one another because our opposite angles are congruent. And JH is congruent to HJ. Well, it's the same segment here. So a segment is congruent to itself by the reflexive property. All right. And then our last statement is we actually do have enough to show the triangles are congruent here. So we can say now that we've said these three pieces of information, we can say that triangle JGH is congruent to triangle HKJ. And the reason that we can make this statement, let's take a look. This is the hypotenuse of a triangle, right? It's side opposite the right angle. Right? So this is the hypotenuse. It's the hypotenuse of both triangles. This is a leg of triangle JGH. This is a leg of triangle HKJ. So our reason is hypotenuse, leg, triangle, congruence theorem. All right, that's why our triangles are congruent. So here's a little proof that we've done to show that those two triangles are congruent. And you see the proofs really aren't very difficult when we're dealing with congruent triangles. We have some given information, and there's some things that we can say. So long as we remember things like the reflexive property and vertical angles being congruent, and we remember our triangle congruence postulates, this isn't that hard at all. All right, let's look at another problem. There we go. All right, so something that does not prove triangles congruent is side-side angle. So side-side angle is not a universal method to prove triangles congruent because it cannot guarantee one unique triangle will be drawn. Consider the diagram of triangle DEF. If for the second side EF is equal to EG, let me erase that. Okay. So here, instead of EG, if instead of EF we have EG, we have one triangle, we have a right triangle. That would be the minimum distance needed to create a triangle. Or if we put it at let's put an H here. EH, we have another triangle. So you see there's three triangles here. So the only way we're going to get one unique triangle is if we know it's a right triangle. Because if it's a right triangle, the only place I can draw that leg is at EG. Right? And so I have one unique triangle. But if it's not a right triangle, I can either draw the line to go at EF, I can draw it to go at EH. So I can have either an acute triangle or an obtuse triangle. All right, so if EF is greater than EG, two triangles can be drawn, as shown by the dotted segment. Should EF be less than the minimum length needed to create a triangle, EG, no triangle can be drawn. So EG is the minimum distance. Any less than that, we don't have a triangle. EF and EH are the same distance, but notice that it's two different triangles depending on which way we swing that side in. So the possible swing of a side can create two different triangles, which causes a problem with this method. The first triangle below and the last triangle both show side-side angle, but they are not congruent triangles. So here we have, if you see, we have the obtuse triangle here to the left and the acute triangle to the right. They both have side-side angle congruency. However, the triangles are not congruent. So side-side angle does not guarantee congruent triangles. So that's not a way to prove triangles congruent. Here we go. All right, so what type of congruence exists, if any, between the two triangles? All right, so I want you to do, I'm going to go through the thing, I'm going to mark the figures, the congruencies, and then I'm going to ask you to decide on which method you think it is. All right, and then we'll go over the answer, and you'll check your answer. Okay, so do this on the same paper as your proof, and you'll turn these notes in. All right, so let's mark what we're given. We're given that QR is congruent to XZ. Something seems strange about that. Okay, oops, XZ. Get rid of that. Okay, and we're given that RS is congruent to YZ. Okay, there we go. All right, so now you need to decide what type of congruence exists, if any, between the two triangles. You have your choices: side, 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 angle, 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 side, hypotenuse, leg, are not congruent. So take a look at the figure and decide which of these six applies. Pause the tape and welcome back. We're going to go over the answer. All right, so if you can see here, if XY, I'm just going to put a mark in here, even though this isn't true. Right? If that were congruent, we'd have side, angle, side. So I'm going to erase that because that's not really true. And if XZ was congruent to QS, if that one was marked, then we'd have a hypotenuse and a leg. And so we'd have hypotenuse, leg. However, that's not marked congruent either. So based on what we have, our triangles are not congruent because we have a leg marked congruent to a hypotenuse. So not congruent. Nope, nothing up there. All right, so if you said not congruent, you got it right. If you made a mistake, just mark it, and then you can put the correct answer. All right, come on. All right, so what type of congruence exists, if any, between our two triangles? All right, so everything I'm going to mark is marked. Pause the tape, decide on your answer, and then start the tape back up again, and then you can check your answer. And then if you think they're congruent, so if you choose not congruent, don't write a congruent statement. But if you think they're congruent, write the congruent statement that matches the corresponding parts. Okay? Okay, welcome back. All right, so if you notice here, we have an angle, two angles are marked, and the included side So if we have two angles in one triangle, congruent to two angles in another triangle, and the included side is congruent, and the included sides are congruent, we have angle, side, angle, triangle congruence postulate. All right, so those triangles are congruent using angle, side, angle, and the congruent statement, one way you could write it, is triangle LMN is congruent to triangle OPQ. Oops. I said O and I wrote a Q. OPQ. Right? And if your letters are a different order, that's okay. It's still correct so long as you matched up the congruent parts. So long as you matched up angle L with angle O and angle M with angle P and angle N with angle Q. Okay? All right, so let's try this one. What type of congruence exists, if any, between the two triangles? There is nothing else I can mark, right, than what's there. So decide your answer. And if you think the triangles are congruent, then write the congruent statement. If you don't think they're congruent, then don't write a congruent statement. Just put no congruent. All right, so pause the tape and decide on your answer. Welcome back. All right, so here we've got an angle. Angle A is congruent to angle D. And we have AC is congruent to DF. That's all we have. And two parts just isn't enough. So they're not congruent. No congruent statement can be made. All right, let's try this one. All right, what type of congruence, if any, exists between the two triangles? All right, decide on your answer, and then if you think they're congruent, then write the congruent statement, and then start the tape and check your answer, okay? All right, welcome back. Well, we've got two sides and the included angle. We have side, angle, side, triangle congruence postulate, and a congruent statement we could write triangle TVU congruent to triangle WYX. So those triangles are congruent using side, angle, side. Okay. Let's try another one. Let's change tapes a little faster. All right, there's one thing that can be marked that's not marked. And that is that YW is congruent to YW. Hopefully you remember that's using the reflexive property. Right? Segment is congruent to itself. Angle is congruent to itself using the reflexive property. Reflexive property. All right, so I'm going to mark the congruent part. All right, so now decide what type of congruence, if any, exists between the two triangles. If you state that they're congruent, write the congruent statement. Okay, so see you in a moment. Welcome back. Two angles and a side. WY is not the included side. It is not between angle Q and angle W and angle E and angle W. So we have angle, angle, side, triangle congruence. And one congruent statement we could make is triangle WQY congruent to triangle WEY. And there we have our statement. So if you're having any trouble with these, let me know, and I can help you. Okay, let's take a look at the next one. Here it comes. All right, so I have no more to mark. What type of congruence exists, if any, between the two triangles? Decide on which postulate here, if any, and then if it's congruent, what's the congruent statement? All right, see you in a moment. Okay, welcome back. All right, let's take a look here. We have two sides and an angle, but notice this is the included angle here. That looks a little messy. It looks like induded. Included angle is N right here. The included angle is L. What we have is side-side angle, and that's not a congruence postulate. So we are not congruent. These triangles are not congruent. All right, so if you said not congruent, you got it correct. All right, let's try the next one. All right. All right, what type of congruence exists, if any, between the two triangles? There's one other thing I can mark. I can mark that HF is congruent to HF using the reflexive property. All right, so decide what type of congruence exists, if any, between the two triangles. If you think they're congruent, what's the congruent statement? All right, so pause the tape, answer the question, and check your answer. Welcome back. Well, this side here, GF and EF are opposite the right angle. That is a hypotenuse in a right triangle. And I didn't mark it. Sorry, I wrote it down here. Hope you, and I forgot to mark this. All right, there we go. And that would be the leg. And that leg is shared. So we have the hypotenuse and we have the leg. We can use hypotenuse leg. One triangle congruent statement we could make is triangle EFH congruent to triangle GFH. Okay, and there we've shown that these triangles are congruent between the given information, the reflexive property that gave us enough to use hypotenuse leg. All right, let's look at another question. All right, what type of congruence exists, if any, between the two triangles? All right, so there's one thing we can mark that's not marked. And that is that BF is congruent to FB using the reflexive property. All right, so decide if any of these congruence postulates applies, and if so, write the congruent statement. All right, so be back in a moment. Welcome back. All right, so we have three sides of one triangle congruent to three sides of another triangle, so we can use side, side, side. One triangle congruent statement we can make is triangle KFB is congruent to triangle MBF. And there we go. Another one done. Okay, so I hope you're finding these not too bad, not too difficult. All right. So what type of congruence exists, if any, between the two triangles? It's really hard to see this, but there is a parallel line marking here. All right. So what angles are congruent when the parallel lines are cut by a transversal? So YO is the transversal. Okay. PO and YU are the parallel lines. And so along on either side, we have angle POY congruent to angle UYO. And remember from class, these are alternate interior angles. So we have alternate interior angles created by parallel lines are congruent. Right? So we have a pair of angles congruent. We also have that shared side, so YO is congruent to OY, and that's using the reflexive property. All right, so let me mark that. All right, so decide which of our congruent statements applies, and then come back and check your answer. And welcome back. So we have two angles and a side. Notice the side between the two angles is PO and UY, not OY. So we have angle, angle, side, triangle congruence postulate. One congruent statement we can make is triangle POY is congruent to triangle UYO. All right, and this one is done.